All human beings owe their lives to deaths of stars, and the quest for answers begins out somewhere in space where a cloud of dust and hydrogen gas, known as a nebulae, is hovering in the interstellar desert. And it's the same force that keeps us here on Earth that pulls things together in a way that forms planets. So, if one of those clouds of dust is large enough, gravity will cause it to collapse and fold in itself. The particles will get hotter and get closer together, creating pressure, then becoming a protostar. The hydrogen core of the protostar will then get so hot it will sustain thermonuclear fusion, which sounds complicated but it's rather simple, being when hydrogen is moving so fast that it fuses together making helium, and this is the energy source for every star. Although the life for a star after this is dependent on its size at birth, larger stars will burn brighter and die faster, only living for a few million years, whereas smaller stars such as a red dwarf may burn dimmer but can live up to 100 billion years. Once born, a star is in a constant battle, being in a balance between gravity, which is making the star collapse in on itself, and the pressure from the core, which is pushing outwards. This is how a star will spend the majority of its life. This phase is known as the main sequence. At some point later in its life, the hydrogen atoms start to run out, and when that happens, the star will start to collapse in on itself under its own weight. It will get denser and hotter to the point where helium atoms fuse together, making carbon and oxygen, the next heavier elements on the periodic table. The star begins to fuse helium, it creates more energy, and that causes the outer layers of the star to expand to what is known as a red giant. This is the beginning of the end for stars. Red giants are large and bright with cooler surfaces. During this period, stars will exhaust the helium in their cores. One day, our sun will grow so large it will swallow up the inner planets of our solar system out as far as the Earth. What happens is the outer layers of the star get farther from the core, the force of gravity they feel gets weaker, until the star loses hold of its outer atmosphere. The outer layers drift out into space in a shell of gas and expand, becoming a planetary nebulae. Once the outer layers have drifted away, they reveal all that is left of the star, a white dwarf. This is what was illuminating those layers of the planetary nebulae. A white dwarf is a dead remnant core of the star at the end of its life. This is an extraordinarily dense object, having the mass of maybe half the Sun, but only being around the size of the Earth. A white dwarf has no nuclear fusions happening and is dead, but yet still incredibly hot, and over millions of years it gradually cools down, then becoming a black dwarf. However, some stars are quite larger than our Sun, growing up to 100 times its size, and these larger stars will lead different lives. They get bigger and bigger, thus being able to fuse heavier elements inside their core, all the way up to iron. And once iron core is formed, there's no more energy that can be attained from the fusion, and the core collapses. The rest of the star follows, but then it bounces back off. Bang! Resulting in a shockwave in just a second. The outer layers of the star are blasted off into space, and these are called supernova explosions. They can be so powerful that they can outshine the whole galaxy which it is part of. For these huge stars, what is left is a super dense core known as a neutron star, which is formed by the protons and electrons combining. These neutron stars can have the mass of which is greater than our Sun, but only 20 kilometers or less across. For the largest stars, such as supergiants, it is thought that when they die, they won't be able to withstand their own gravity and become black holes. So, stars are actually the place in the universe where elements are created. We are all made of stardust. Almost every element on Earth was formed at the heart of the star. After the Big Bang, our universe contained only hydrogen and helium. All other heavier elements were therefore fused inside stars. Virtually everything you see around you was made inside stars billions of years ago, before the sun and planets were formed, and when these stars died and blasted out into space, they spread the raw materials from which our sun, the planets, and even ourselves are made of.
It can be compared that hydrogen joining together, making helium, being the energy source of the star, can be compared to two human sex cells that are joined together at the start of a human life. It can be compared that both the stars and a human's life, we are weak and we get stronger and stronger until we reach the height of our existence. Then both stars and humans slowly become less efficient at doing what they do until eventually they cannot sustain themselves any further.